Hello everyone, December 16th. All right. This is the challenge for today. And then I go back to this one. Man. So yesterday we checked one hint. So today I'm going to check the second hint, see if we can get anything. I do think the general idea that we have is right? We try to match them. But the problem I had is you can't just match them whatever. Right? You have to have a certain order to match. And when you dig deep into the order, and then things just got very, it just doesn't feel right? It doesn't feel right. So we're gonna see what other hints can we have. All right, so we first do this. Evaluate the value of an arithmetic expression in reverse Polish notation. Valid operation, blah, blah, blah. Each operand may be an integer or another expression. Division between two should truncate towards 0. What does that mean, truncate towards 0? That's 2, so only integers. Given reverse Polish notation is always valid. It means the expression would always evaluate a result. There will not be any division by 0 operation. So what the hell is a reverse Polish notation? These two plus these two multiply. So these, so this will be 9 plus 3, 12, so it'll be 18. Wait, hold on. So 9 plus 3 is 12. And 6 and 12. Wait. That's not how I expect it to be. 9 plus 3. Oh, my bad. This one is gone. And then multiply by minus 7, and then divide 6 divided this. And then whatever is 10 times, whatever plus 7, whatever plus 5. And then plus 5. Just a stack. So yeah, that's not anything too hard. Rest equals 0, and we just say stack is this for a token t in tokens, right? If t, no, that's not right, is alpha. No, is num? What's the function again? Is decimal. Yep, is decimal. If it's decimal, stack dot append t. We'll probably just do int t. Else, do we? Wow, we can do this. What? Mul add how do I do division? I don't know how to. There's neg. Do we not have something for that? All right, let's just lambda it. That'll be easier. So what do we have? We have plus b plus b minus ab. All right, multiply all right, else, so it's not, so it's gonna be in a operator. So what I do, I just pop the 2. All right, I'm gonna say ba shall equal to stack.pop. Stack.pop. Which one gets popped first? I think this one gets popped first. Okay, and then stack.append OPs T AB. I will return stack 0, or actually I should split that -1. That will be better one. Token length can be 1. Ha! What are you talking about? What I'm saying is we can have 10 and we shall return 10. That should be correct. Well, tokens. No way. No way. Oh. Oh. My. If what do we do? If t a decimal or t0 is equal to minus and len t is larger than 0. That is what I can do. Because the minus sign is just by itself. So if there is a minus, it has to be a number. Okay, so we have not passed this. Ooh, that is not expected. Let's print the stack and examine. 10, 6, 9, 3, so we get 12. Minus 11. Yes, we got minus 132. And 6 divided by minus. That shall be 0. Kidding me? Okay. How about minus 6 divided by 132? Ew. This is ugly. How about we do math dot floor? Nah, that doesn't work. Hold on. Maybe it works, but we don't do this, we do this. Nah. And we cannot do ceiling. Ceiling for other things is not working. Man. My man. We want it towards 0. can say if a times b is larger or equal to 0, else a divided by b and a plus 1 to tie it. Well, I need to try something. Okay. That looks promising. Ay, ay, ay. That was unexpected. Oh, wow. Hold a sec. What? Huh? That should be -2, right? Well, did not run through them well enough. I'll become -1. Nah. Okay. Screw this. Oh, screw you. I was trying to be fancy, but didn't work. How did I resolve last time? I suppose it's the same way. Division given negative values. How did I do last time? Look at that. Hi, screw me. Oh, look at this. Oh, why do you do this way? Int. Did not realize. Yeah, it should be int. It's not difficult. All we need to do is int a divided by b. I did not realize that. Plus. Oh, why do you even do this? I don't know. Ooh, the pop, the order. I just need to, all these has to be BA. Yep. Why you use this? All right, hint number 2. What do we have? It can be seen that greedily wrapping values of indices where this and this is the most optimal choice. How many values cannot be swapped this way? Well, there will be values you cannot swap this way. There will be some things left. Okay, we did this already. What's the last hint? Find which indices we will swap these remaining values with, and if there are enough such indices. Yeah, that's the question. I mean, we can swap them. Greedy, yeah, we can swap them. That's what I did. But the question is, how do we handle this swap thing? Right? You pair them up, right? You can pair them up, and the current strategy is I'll sort them, right? So the largest one will be paired with, so the smaller ones won't pair with each other. They all pair with the big ones. So once we're all done, we'll have something left. Now the issue is when the something is left, that thing, if I choose which one to pair, then it is possible that we can pair with the first one. So what do you say? So I mean, at the eventually, right, we try to pair with the largest, and something will get left. Or you say we can choose which one. I wish we should swap. Yeah, we have. Oh. put 37. Oh my god. The hint is basically what we already did, so nothing is actually helping. Alright, so we have 2, 1, 2, 2, 1, 4, 1, 5. 2, 1, 2, 2, 1, 4, 1, 5. Oh my god, that's exactly the same. Damn. So we have 2, 0, 2, 3, 1, 1, 4, 6, and 4, 5, 5, 7. Okay. What if we want to get a front first? Right? If the front is swapped, then later on we can always swap with the front. Okay, let's say we want to swap 2. So we can swap 2 and 1. It doesn't matter, so we have 0 plus 1, 2 plus 4. Hold on. 16. That's 28. How? Well, because of this stupid things, I might have done something wrong here. Yeah, this doesn't sound right. But if we don't do that, then how we handle the order? How do we handle the order? Do we have something that we need to handle the order? Hold on, let's not do this and see what happens. Okay. Now the remaining all wrong. Yeah, that's the one. So we have 4. Position is 1. 3, the position is 3. 7, at 2, the position is 7, right? So we need to order them. Let's say we want to do, because that's 3, 4, 4, 4, something, right? Let's say we want to handle the earlier first, right? If we sort them into 1, 3, 7, so we say we'll swap 4 and 3, and then we'll swap 2 with the start. Let's try this. So first of all, we don't do any of this. We will sort based on, we will sort them, but based on indices k 0, the first occurrences. Okay, that's how we're gonna sort. And then what? But you also want them to match. Huh. You also want them to match. But to match, well, if we can match, that's definitely better, but it'll be hard to say. Yeah, matching is good, right? Matching is good. Because we're not wasting. So what do we say? We get a match. Okay, we get a match. And then after matching, we will have something left. Yeah, they all have the same size, right? They go together. And then we just compute them, right? And then we'll have the remainder. We'll have the remainder. Okay, so the goal is to match them. Match the length. What if there are 3? They have the same length. Oh, you handle 2 first. But you need to handle the 2 based on count. If we only have 1, if we have 1, yeah, you shouldn't. If let's say we have 3 1s and have 1 3, we shouldn't match the 1 together. This is just, I don't know, like, what type of analysis are we supposed to do? I don't know. It's just complicated. I'm giving up. All right. Huh. Uh-huh. Yes. Yes, it is free to move. Because we use this, as long as it doesn't move back to the old position, it'll be fine. Yeah, but it's fine because what we're doing is those swap. So we come here and then come here, so they have to take it. They are free to move. Holy crap, they are free to move. So as long as they don't go back to the same position, that should be fine. There's not enough. 0, 1, 2, 3. Yeah, but we want to have 1, 2, 3 to distribute. Ah, that's what it means. Not half. It's just if you take out them, or you take them out, put them there, and then there's not enough to put them back. What do you mean there's not enough to put them back? Because when you take these out, so we have 2, 2, 2, 3 to distribute, right? 2, 2, 2, 3 to distribute. But so when we remove this, remaining is because the maximum count here is 3, but this maximum count is 2, right? Which means if we redistribute, there gotta be an overlap. So the max occurring, if we have more, oh, a max occurrence is this much. If a smaller max occurring, so basically it's just saying the max occurring here, not really max occurring, just the value occurred in these bad indices, right? And the values occurred in the good indices, not good indices in the 2. If these two added together is equal to, then we just perfectly can distribute there and it will be fine. But if these two added is larger than the available space, then we need to keep taking, right? We need to keep taking the smallest indice out. So in this case, we have 3 on 2. We don't have 2 on 2. So 2 plus 3 is 5, but we only have 4 spots. So they gotta be overlapped. So we cannot do that. So we have to take this 1 out. Then we have all 5 position open. Okay, so now we have all 5 position open. How do we do? Well, we can distribute them however we want, and it's free, right? It's free. We can distribute however we want because we basically just move here and move something to another place. It's just the same as swapping them. So how do we distribute them? We basically just say how do we distribute them? We can distribute however we want, right? So we can go through the first one and the first, and then we do it, move on to the next one, and then we check it's the same. Then we how do we distribute? Oh, we don't have to, we just add them together. Yeah, because it's the same. We add them together. Wow, this is a great. So what are we saying? What we're saying is we move everything to 0. How we distribute. Well, hold on. Wait, we do need a bad thing. We just need the indices. We do need the indices and we need a count. Okay, we need some stuff, right? We need some stuff. We need the indices. And yes. And what else do we need? We need to find out, because every time we do this, we basically put it into the front, right? And we need to count on the second one. We need to count. Right, and then we count the largest. So indices, and then we have a count, num2 count, right? Oof. Okay, so we have a counter. So every time these two, and I remove, right? Then what? Then we say nums2 count n plus equal 1. Right, because they're the same. So we count and we remove. How many do we have? Remove how many do we have? And then if all these, then we need to have all these as well, right? So blah blah blah. Then we say indices nums1 0, because this has to be append 0, right? And then nums2 count nums2 0 has to be plus equal 1, right? We actually just add them together, which is fine. But no, let's just keep it this way. Okay? So now we have the raw material. Then we just need to see the maximum, right? We can sort based on length. So we know the maximum, so we do that. And then we need to see what else do we need to put in, right? We need to see what else do we put in. Oh, we also have to have available remaining indices. Right, and then we say else. Okay. And then we're going to sort the keys. And for each one, we add to this. And we need to know the total number of availability. Right, and then the total number of availability, num2 distribute shall be n minus len remaining indices. That's the number to distribute. And then we just need to see if Okay, so we say for key in sorted. Okay, that's gonna be len. Nope. It's gonna be minus length. Okay. So now the first key will be the largest, with the largest length. And then we need to see if this plus this is good, right? Then we say if len indices k plus nums to count k. If this is larger than just say count to distribute, right? Then we have to add additional into this, right? We have to add additional into this thing. I know, now that made me think we only need the count. What do you mean? What I mean is we don't even need indices. We just need a counter, nums1 counter. Alright, we just need to count. And we need this count. So we need a counter and we just need the sum. Because they have to, no matter what. So what you're saying is we have nums1 count. Alright? As I can distribute however we want. So let's say we do a counter here. And then remaining we have a rest is here. And then blah blah blah. We say let's say C1, C2. C1, C2 are two counters. And then this can be C1 n plus equal 1 and C2n plus equal 1. Right? That will be the same. Yeah, because they're the same, they're the same, they're the same, they're the same. So we count them. And then we have to count at a position 0. Right? We count position 0 as well. If position 0 is not in it already. Yeah, it's the available position for the second, available position for the first. Okay, so and then res plus equal to I, right? Because these has to be moved no matter what. And once we're done, right? Yeah, once we're done, then we say if nums1 0 is not equal to nums2 0, then C1 nums1 0, this one is plus equal 1. This one need to be distributed because we are all on this. And C2 nums2 0 plus 1. This is the position that can be distributed, right? So when this is the case, and then we just add 0 so we don't have to add it. All right, and then the available for distribute is this. This is the total available for distribution. Aleph Yeah, 0, it needs to be distributed. 0 cannot come with this. So this is the total number can be distributed, right? Then all we need to do is just sort. I think counter has most common, right? Yeah. Most common. Okay, so we say for key value in C1.most common, right? Then we can say if V plus C2K, I mean, we can actually just go, we can go just for this in range. If this is larger than, then we need to take the good ones, right? Then we say if not RAM indices. We need an index. We need an index. Let's put a J. Okay. So if J is equal to blend RAM indices, that's when we say return -1 because we don't have enough room to handle all those. Right. Otherwise, if J is not equal to, then then we say while, I'm just say for this in range V plus C2K minus, right, count to distribution, because we just don't have enough. We will take the smallest. How do we take the smallest? We can actually do it here. If not, then we say res plus equal to remaining indices, J, right? We take this out, and then after take this out, J plus equal 1, and count to distribute plus equal 1. We have more to distribute. But if they hold on. Yeah, after this one is done, then the remaining shall be fine, right? The maximum count, and this we can handle them. Then the remaining shall be fine. It should not be larger. But we just put this here, just in case we have another one. But it shouldn't be, right? Because we have, this is already larger than half. So the remaining is definitely smaller than half. We have this, so the remaining, so if we extend, the remaining must be half, more than, right? So the next one must be smaller than half, and that plus this. I was wondering if it is necessary to do a loop here. Or we just consider the most common. We don't have to consider, so we consider the most common one, right? So imagine the most common on the top and at the bottom, if they add up together, is more, then we need to extend, right? And then if the next one also happens, then we need to extend again. The question is, would it be possible the next one also? No, I think it's okay. We just go through this. It won't take too long. Yeah, and every time count distributor will increase. And once we're done, we just return res. That's not right. Because I forgot I changed this value. Oh my god. Ooh, it's correct now. Oh my god, they're all correct. Oh dear lord, they're all correct. Oh my. It's great intuition, huh? We move all the numbers that need to be swapped on bad indices to index 0. Then the job is to redistribute them to the spaces available. Redistribute them to the spaces available such that we can create a new array, right, that is not identical to nums 2. The important thing is that this redistribution is free because we come to index 0 first, right? And then we say the current bad index is I and j. Then we just need to redistribute to j and I, and essentially making a swap between I and j, and we are done. Thus, after collecting all the bad indices at index 0, we the redistribution, right? The cost of redistribution is just the sum of all the collected indices. Now the tricky part is that sometimes is that we also include the values at index 0, right? Also include the value at index 0 for redistribution. While everything else, we include that for redistribution. Now, that's not the tricky part. Let's note that after collecting bad indices, the value in nums 0 is also included in the numbers for redistribution. And its redistribution has no cost because its index is 0. The tricky part is that depending on the situation in nums 2, we might not be able to redistribute everything, right? From not to distribute every value. For instance, nums 1 equal to, I like this example. I'm gonna upvote this example. Two, 2, 2, 3, 3. 2, 2, 3, 2, 2, 3, 2, 2, 3, 1. After collection, we have 2, 2, 2, 3 at the number to be distributed. The numbers to be redistributed are this. The positions available for redistribution, also the position in nums 2 are 3, 2, 2, 3. All right. Notice that there are 3 2's in the redistributed values and 2 2's in the available positions according to nums 2. The sum of these two counts is 5, which is larger than the count of total available spots. Hence, if we redistribute like this, we will definitely end up with 1 2 with one of the 2's in nums1 overlapping with one of the 2's in nums2. Hence, when this situation happens, we need to include even more. We need to include more values from nums1 for redistribution, which in turn increases the available pool of positions for redistribution, available spots. And to reduce the cost, when when new indices are included, we always use the smallest ones. The end goal is that all the count of each redistributed values plus the count of its occurrences in nums2, right, in the available spots have some smaller or equal to the total count of the available spots. This way, we can guarantee that each value can be redistributed without overlapping. Yeah, can be redistributed. So count 1, count 2. Count the occurrences, right, of bad indices on both. Index I must be included. Index I is inevitable cost. This is to record the good indices in order. This is to include the values at index 0 for redistribution. Here's available spots, we know. Yeah. We need to include good indices as well. No more good indices, but we still need more spots in possible case. All right, we're gonna copy and paste this. Okay, oh no, not here. Do good test case here. Oh. If it all passes, then we'll submit. No, what? thought we're done. This is not right. Hold on. Everything passes here, but damn. Number 8. What? Dude, this is not looking good. Oh my god. You read the solution, it's still not enough. Expected 8. Alright. Yep, don't give up. Just keep working on this. My god. Ah, if this is not nightmare, I don't know what is. Alright, so we have so 1, 3. And then the one we need to move is 5, 4, 4. Right? 5, 4, 4 we need to redistribute. Okay, so we have 2 in this. Right, and then we have 2 available spots. So 2 plus 2 is 4. And we don't have 4, we only have 2. So we need to move, right, the available spot. And this is also a available spot. Oh, this is a 1. But this is also a available spot. Oh, 5. No. Yeah, so we have 3 and a 3. We have 3. So we have 2, 4 on the top, 2, 4 at the bottom. So we have 4, but we won't have 3 spots. Now in that case, we need to include 1. Okay? So we need to include 2. So now we have 3. Also need to go. Now we have, this is also a available spot. Now what do we have? Now we have, oh, that's now 3. That's a 4. Holy crap. That's a 4. Oh man. Oh man. Because when you remove, you can remove. Oh man. Oh god. Oh god. Okay, now it's serious. We need to consider. Maybe we only need to consider the largest value, and the remaining we don't have to worry. Because it changes. Right, it changes, so the maximum gets even bigger. Right, it gets even bigger. Can we say that if we satisfy the maximum, right, if the maximum is good, that on the top, right, the maximum is good, because those are the spots, right? So it should be the same count, right? It should be the same count. We have the same count on the top, the same count at the bottom for the bad ones, and then we take 0, the 0 position out as well. So when we take 0 position out, we have some count on the bottom as well, some count on the top. But overall, they're all matching, right? They're matching because they're bad indices, so they're all matching. And then if I have too many of those, right, then we don't have enough. If we don't have enough, so we need to take some away. And the only case that it's not enough is because the top, it's already more than half. If it's not more than half, then we shall be fine. So all we need to do is to make sure the top is, yeah, so everybody else should be fine. So all we need to do, all we need to handle is the top, is the maximum on the top. Okay, so all we need here is, okay, I don't even need to use this, equals c1.most common. I just need one. What is the most common? Okay, I just need to handle the most common. Everybody else will be fine. Yeah, because it dominates, right? So while c1k plus c2k larger than available distribution, then we just take 1. All right, we just take 1. Again, we say if j is equal to, we can just do this. Otherwise, we add this, j plus equal 1, available spot. Yes, and c1k, right? c1 position j. So c1 nums 1. Oh my god. Nums 1, this plus equal 1. c2 nums 2 plus equal 1, right? And then we go back up, right? Try it again to see if it works. If it works, then done. Otherwise, we don't. Huh? Oh, my bad. Ew. Oh, dude. 0, 0. Still not right. So we have 4, right? And then what's, yeah, 2 and 4. And then we get 2. Then we have 3 plus 2, because remaining is 4. Right? Remaining is 4. Hold on. Available is 3, yeah? So remaining is 4. And then nums 1. remaining indices. Oh, let's handle this at the end. Now to become 10. Gotta be kidding me. Wow, it is 10. 0, 1, 2, 3, 4. Yeah, 1, 2, 3, 4. I'm taking all of them. Wait, what? That's 6. Wait, hold on. This position have 5, 4, 4. Alright? And then this position is open, this position, this. Open, 5 and 2. And then we want to redistribute. But at this position original. No, this should be. Right. So we have 2 false and I have 2 false, so it's not enough. So we need to take another one. Right, we need to take another one. So we take the smallest is here. This is bonkers. So it's saying we should not take the ones. Yeah, if we take that, we say if k is not equal to when we take good indices, do not use the same. Do not take number. Do not take the same number as the most frequent. Okay. I don't have any confidence now. Still not right. Okay, how about this? If it's not equal to, that's fine, right? Else, if they're equal, then we have to add 2 at this, and then we'll have to add another one. And that's definitely going to be worse than, so I will say if this is not equal to this, no, that's not what we're looking for. Is this is a number we're trying to take. I say if the number we're trying to take, which is let's just take it, okay? Let's say let's take it, right? And after take it, we can say if C1k plus C2k is still larger than this, then we revert. And then we try the next one. Else, that's bonkers. Why is this not right? We try the first one, right? And then I see if it's, after I take it, if it's good. If it's not good, I take it back. And if it is good, I say I'll take it. Why is it not right? Man. 3-0. Wait, what? Yeah, that's correct. And then 2 plus 3 is 5. 5 is larger than plus 1. It has to be larger than this. If larger than this, then we cancel. Otherwise, we keep going. Always include current smallest index smallest available index. But if including it still doesn't resolve our issue, skip the current, because otherwise we would have to do more swaps. If this one still fail, I'm gonna end it today and then check the solution tomorrow. My God, what the hell? Guacamole. Which one? Which one are we failing? Nah, this is very bad. This is extremely bad. I mean, I'm kind of using my own idea to solving this, but this is extremely bad. I don't know, just throw something at it. I don't even know where the error is located. Okay. At least inside here. We got a -1. Okay, the last, let's say we give the last few. Second one. Alright, I'll do this tomorrow. Oh my God, this problem's been lasting for so long. Unbelievable. Alright, I'll go back tomorrow. I've been stuck for like 4 or 5 days.